Hello, everybody.
Investment.
It is me, back at it again. Today we're doing the AJHSME 1985 still, but this time we're doing problems 11 through 15. So this is going to be fun. I'm joined here by my friend Chinggis Prophet number 2.
My name is Chinggis.
Prophet number 2.
Chinggis.
Prophet number 2. Okay, and I am Box. So let's begin with the AJHSME 1985 11 through 15. Piece of paper. Let's start with 11. A piece of paper containing 6 joint squares is labeled as shown in the diagram. As shown in the diagram, is folded along the edges of the squares to form a cube. The label of the face opposite the thing labeled X is... Okay, so this is my first time doing all of these problems, so...
Same here. So if we
Same,
ever
bro.
get stumped, just
Yeah, okay. So
forward ahead.
let's think about this. Okay, so let's start with just X and Z, this corner. Okay, so if we draw a cube with X as the bottom, which is what we're going to want to do, right? X, then this side is going to have to be Z, because think about it. This is fold up here, so Z is going to be at a right angle of X. So this is Z. And then this side over here, and then this side over here. Okay, wait. Yeah. And then so there's that. And then so then we have another X, right? X. And then on the other side of Z, so this side is Z, then this side is going to have to be V because these are opposite. So V is going to be folded up here. It's going to be at a right angle to X still, right? So this side is going to be Z and then V. And then U and W have to be opposite each other. Because think about it. If you fold W onto V and U onto V, then they're both going to be opposite each other, meaning that neither of them can be opposite of X. So V and Z are opposite, U and W are opposite, and the only thing that's left is X and Y. So they have to be opposite. So we're finding the opposite of the face labeled X. So our answer is Y. Here you go, Chinggis Prophet. Number 2.
Okay. I was doing pretty good. Anyways. Hi guys. Okay. We're gonna be doing problem 12. So problem 12 says a square and a triangle have equal perimeters. The lengths of 3 sides of the triangle are 6.2, 8.3, and 9.5 centimeters. The area of the square is question mark. So, first we want to approach this problem. So how do we do that? So, let's just first, because I don't like geometry, so let's draw this out. Oh my god, this is really... No, I got this. I will do this with the end. Okay. Boom. Okay, so now, so let's say we had a square. I don't like this color actually. I'm really picky. There we go. Now let's erase this. This is boring. And okay, so unfortunately we're in battery saver mode, so this really sucks. But it's fine. So let's actually start now. We have a square and we have a triangle. Let's say the sides of the square are, I don't know, A. Then the perimeter is 4A. And let's say the sides of these are B, B, and B, and the perimeter is 3B. And because they're equal, 4A equals 3B, which means that 4 divided by 3 times A is equal to B. Now, the lengths of the 3 sides are, I can't see that anymore, 6.2, 8.3, and 9.5, which means that if you were to add them up, you would get what? 6.2 plus 8.3, that's going to be 14.5. That plus 9.5 is going to be 24. So the perimeter is equal to 24, which means that the triangle perimeter is 24, and then 4/3 of the square perimeter is 24, which means that A, the perimeter of the square... Oh, I messed up real bad.
Stupid. No, the perimeter of the square is 24.
Sorry. No, it's not.
Yes,
Oh, yeah,
it
it is. Sorry. Okay, let's start now. Okay, so the perimeter of the triangle is gonna be 24, right? Now the triangle Oh wait, no. God, I'm really bad at this. Now the square has the same perimeter. Let's say the square, that's not really a square, that's a rectangle. Let's just draw better. That's an okay square. A, and A, right? So 4A, which is a perimeter, is equal to 24. Which is because they have the same perimeter. Now what that means is and I did 4A because they have to have the same sides, but for the triangle they don't. But yeah, so that means that the length of the square is A is equal to 6, which means that the area of it is going to be 6 squared, or 36. I'm sorry, that took long.
Thank you, Mr. Prophet.
Genius.
Thank you, Prophet. Okay. So let's just erase this stuff over here because it's covering my problem. Okay, problem number 13. If you walk for 45 minutes at a rate of 4 miles an hour and then run for 30 minutes at a rate of 10 miles an hour, how many miles will you have gone at the end of the 1 hour and 15 minutes? Okay, so let's take this problem step by step. Shut up. Okay, so we have 45 minutes at 4 miles an hour. Miles per hour, right? And then we have 30 minutes at 10 miles per hour. So, okay, so 1 hour is 60 minutes, right? And so that means that the amount of miles that you've gone for the 45 minutes at 4 miles an hour is going to be 45 divided by 60 times 4. Because think about it, right? So you have 45 minutes. So let's do 45 minutes times 4 miles per 60 minutes. Right? So then we're going to have to divide this by 60 minutes because that's the number of hours. So 45 divided by 60 is 3 divided by 4. And then that times 4, these two cancel, we get 3. So that's 3 miles that you've gone. And then we have 30 minutes at 10 miles an hour. So 30 is half of 1 hour. So you've gone half of an hour, meaning you've gone half of 10 miles. So you've gone 5 miles. So you have 5 miles plus 3 miles, which is, why am I writing M? Which is 8 miles per hour. 8 miles. Yay! Okay, now back on to Chinggis Prophet.
Chinggis. Now, anyways, for problem 14, me, Chinggis, will be doing problem 14. And I'll do it a little faster this time because I'm a dumb bum. So the difference between a 6.5% sales tax and a 6% sales tax on an item priced at $20 before tax is question mark. So let's say that we add 6.5% sales tax. That would mean 6.5 over 100. Or sorry, 106.5 over 100. And I'm not gonna solve it. That's gonna be boring. And that times $20, and then that minus the 6%, so that's 106 instead. 100, yeah, sorry guys, times 20. So now we can factor out a 20, right? And we're gonna get 20 times 106.5 over 100 minus 106 over 100. Now what I see here is that these have a common denominator, so I can do like that. And now this top just becomes 0.5 over 100, which in other words is 1/2 over 100, or 1 over 200. So I'm just going to go over here because there's lots of free space. That's going to be 20 times 1/2 over 100, and that's going to be 20 times 1 over 200. Like I said, just wanted to review. And then 20 times that is going to be equal to 1/10. So 1/10 is going to be, so 1/10 of $20 is going to be, wait.
Okay, so it's 20 times 1 divided by 200.
Yeah, that's going to be 1/10.
Which is going to be 1/10. So your answer is 1/10 of a dollar, which is
0.01. Yeah, 0.1.
Yes.
B. Sorry, guys.
Okay, now it's on to me. Thank you, Chinggis Prophet. Prophet. Okay, how many whole numbers between 100 and 400 contain the digit 2? Okay, so this is actually a pretty good problem for one of the most useful tricks that you can have in, what the frick, in math, in contest math specifically. And so this trick is that, so basically instead of counting the number of things which have a 2 in them, it's much easier to count the number of things which don't. So what I mean by that is, let's see how many possibilities there are for the first, second, and what the frick, first, second, and third digit. So we have 1, 2, 3. So the first one, so we're trying to find the numbers that don't have a 2, and then we'll subtract that from the total number of numbers.
And we know that the amount that do have it and plus the amount that don't have it is going to be the total.
Yeah. So okay, so we have, so for the first one we can have 1, 3, or 1 or 3. And then we'll add on the, yes, no, yes, okay. You know what? I think this might actually be easier if we do count the number of things which do have a 2. So, sorry, this is my first time. Okay, so let's count the number of things that do have a 2 in 100. So we have 100, 102, then 112, then 120, 121, all the way to 129, and then 132, 142, 152, 162, 172, 182, 192, right? And then the number of things in this is going to be the same as the number of things which have a starting digit of 3, because that's not going to change anything. And then 2's we'll deal with later. So how many are there? Well, there's 102. So 1, 2, 3. And okay, so there's 1, 2. And then from 20 to 29, there's 10, right? Because it's basically counting the ending digits. You have 0, 1, 2, all the way to 9. So it's 1, 2, all the way to 10. So there's 10 of those. And then for third, so there's 10, 1, 2, 12, 13, 14, 15, 16, 17, 18, 19. So there's 19. And then times 2 for the ones that start with 3. So times 2 is 38, right? And then we need the number of things that start with which have a starting digit of 2. So how many are there? Well, there's 200, 201, all the way to 299. So if we just count the last digits, we have 0, dot, 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 299, right? And then, so 0 all the way to 99, or 1 all the way to 100. You just add 1 to every digit. It's the same number of things. So 1 to 100, obviously, there's 100 numbers plus that 38. 100 plus 38 is equal to 138. So our answer is C. Thank you for watching. This is Box and Chinggis Prophet out.